very brief lesson, or not very brief, but a brief lesson today, closing up chapter 4. We're not going to do any more in chapter 4 because a lot of it actually has stuff in chapter 5 and other chapters. So today what we're going to do is focus on two types of nonlinear patterns. This week we've learned that a linear pattern is one that looks like a line graphically. So again, linear, L-I-N-E. So a linear pattern is one that looks like a line, or the main thing we have is that it increases at the same amount. So the ones that we saw in yesterday's work increase the same amount all the time. So looking at this following set of points, our first thing we want to do for this is make sure that our independent variable, x, in this case, is moving up one at a time. But when you look at your dependent variable, 11 to 16 is adding 5, 16 to 21 is adding 5, 21 to 26 is also adding 5, and 26 to 31 is also adding 5. Because this is the same, that means that this is a linear pattern here, because again it increases steadily at the same amount as your independent variable changes. Our questions for today though will not match immediately. What they're going to do is give us a total of 3 different patterns to look out for. So please take a moment in your notes to write these rules so you can use them today and to study for tomorrow's quiz. The general idea is you're basing it off of the number of checks it takes to make a match, and then this is the pattern type that it is. So if you check once, like we did here, and you get a match after the first check, that means that it is a X pattern, which means that it is linear. Alright, remember yesterday all of our patterns had y equals 3x plus 4 or 7x plus whatever, but we used a regular x. If they don't match on the first one and it takes a second check to make them match, then it is a x squared pattern. Look at the pattern here, 2 goes to a 2, just like 1 goes to a power of 1. If it takes 3 checks to make it match, then it is x to the third. So again, that's one of the things you're going to be asked to do, is tell what type of pattern it is, and that just depends on the number of times you have to check it to make the pattern match. Alright, so again, 1 check is x, 2 checks is x squared, 3 checks is x to the third. Notice how easy though it is to identify the number of checks. Our problems yesterday matched on the first check. We then used the formula to determine the pattern. Each of our patterns yesterday had a regular x because we used the demus, or as I said, it's another version of y equals mx plus b, but anyway, we had a x in there. Today what we're going to do is look at how we approach problems in which the differences take more than 1 check to find a match. Although we used that formula yesterday on linear patterns, you cannot use that pattern to analyze something that is not linear. So what we're going to do instead is use a table. So looking at the following examples real fast before we go to work. The ordered pairs 1, 3, 2, 12, and so on represent a function. What is the rule that represents the function? First, again, we want to make sure that these are increasing by 1, because if they aren't, then we can't safely check the distances of the dependent variable, but they do go up by 1. So looking at 3 to 12, that is plus 9. Looking at 12 to 27, that is plus 15. 27 to 48 is 21. And then 48 to 75, if you're not sure, do second number minus first number. And so 27. Notice that our first check did not make them match. So that means that this is not linear. Do not call this linear because it can't be. It's not moving steadily. Now you check the individuals here. So 9 to 15 is plus 6. 15 to 21 is plus 6. 21 to 27 is plus 6. And so what that means to us, because it took 2 tries to make a match, is that this is an x squared pattern. Okay, so when you see that question today, that's pretty much where you get your answer from. But what we're going to do is use a table to figure this out. And what we're going to do is start with an x, because that's what our value is, put down the type of pattern it is second, and then put the y value down the third one. That way we can look at all the numbers. 1, 2, 3, 4. We can look at all the numbers and make our general assessment based off of that. Tables are usually, anytime you're doing a word problem or a big problem and things are kind of crazy, sometimes, or a lot of times, making a table actually at least lets you see what's going on. Remember that x squared means take x and multiply by itself. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. I don't know where I got that from. 4 times 4 is 16. 5 times 5 is 25. Our actual y values were that 1 led to 3, that 2 led to 12, that 3 led to 27, that 4 actually led to 48, and that 5 actually led to 75. Now what we've got to do is figure out how we get this number to be that number by doing the same thing. And there are three things that usually happen. Either you add a value, you subtract a value, or you multiply a value. So what I usually do is I check add first. 1 plus something makes 3, that is plus 2. But is 4 plus 2 12? No, it's not, which means we're not obviously not adding anything. We obviously also do not subtract to get from 1 to 3, so forget about that one. Multiplication, again, do a real quick check. 1 times 3 is 3. 4 times 3 is also 12. 9 times 3 is 27. 16 times 3 is, I think, 48. It is, and 25 times 5 is 75, which means that we are multiplying by 3. So what we do now is we take our pattern generator, which is what this is, our pattern label, and we simply apply what we know. So how do you show that you multiply x squared by 3? You write the answer of 3x squared. And that is how you identify that pattern. Okay? So again, looking at that, find out, make your x, your whatever your label is, so this time it was x squared, and your y, and then you look and see how you make your x squareds turn into whatever they're supposed to be, and that is how you know to generate your pattern that way. Alright. Got another one here. Another pattern that represents a function they want to rule. Again, make sure your independent values are increasing by 1, which they are. 4 to 11 is plus 7. 11 to 30 is 19. 30 to 67 is 37. And 67 to 128 is 61. So now checking these here, 7 and 19 is 12. 37 and 19 is 18. And 37 to 61 is 24. Notice how the first check didn't work, so it's not linear. The second check did not work, so it's not an x squared. But looking at the third check here, 12 to 18 is 6, 18 to 24 is 6. These two matching here means that obviously it is a match there, and so that means that this is a x to the third pattern because it took 1, 2, 3 checks to get to our final match. So there we go. And again, we are going to use a table here, putting down x, x to the third, and y. And again, what this does for us is it allows us to see everything that's going on with the numbers without having to do too much mental work, because you don't want to have to do all that in that case. Remember that x to the third means take that number times itself 3 times. So 1 times 1 times 1 is always going to be 1. 2 times 2 is 4 times the third 2 is 8. And just to make sure, so you see, there you go. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. And 5 3 times is 125. Now, in all honesty, every time you make this x to the third pattern, these numbers are going to be here in this one because it's always going to be the same, because 1 to the third is 8, 1 to the third is 1, 2 to the third is 8, and so on. So you'll be fine for those of you who like to memorize, this list is always going to be there. Our y values, though, 1 actually led to 4, 2 actually led to 11, 3 actually led to 30, 4 led to 67, and 5 led to 128. And so again, our question now is, how do we get from here to here by doing the same thing? Again, you either add, subtract, or multiply. Those are the only 3 options that you typically have. So looking at it, again, I always check add. 1 plus 3 is 4. 8, if I'm adding 3, is 8 plus 3, 11. Yes, it is. 27 plus 3 is 30. 64 plus 3 is 67. 125 plus 3 is 128. So in other words, what we're doing is we're taking this pattern type and adding 3. Well, how do you show that you're adding 3 to x to the third? you simply put y equals x to the third plus 3. And that is all. Alright, so again, it's not so tough. You just have to make sure you identify what the shift is and then apply that to whatever your type of pattern is. If this was an x squared, then you would have put x squared plus 3 or whatever it might be. And so there you go. Alright. One more example. The ordered pairs 110, 213, 316, and so on represent a function. First off, again, they want a rule. Check to make sure your independent values are going up by 1, which they are. Now, 10 to 13 is plus 3. 13 to 16 is plus 3. 16 to 19 is plus 3. 19 to 22 is plus 3. Notice that this is a regular pattern here, which means that we are not going to use a table. Again, what you don't want to do on tomorrow's quiz is mix this type of work with the linear work. The linear work goes right back to what we know. To where we pick one number, and again, doesn't matter which number it is because that's just like it is in a table, and our dependent value is 10, our change is 3, our independent value here is 1, and again, we're looking for the shift. And so from there, this turns into 10 equals 3 plus whatever our shift number is. Subtract 3 from both sides, you get 7 for your shift. And our answer is y equals, remember your m goes first, so that is this number here, and that number here comes back, so 3x plus 7. And the good thing about these is that you can actually check. 3 times 1 is 3 plus 7 is 10. 2 times 3 is 6 plus 7 is 13. 3 times 3 is 9 plus 7 makes 16, and so on. 4 times 3 is 12 plus 7 makes 19, and so on. So again, that is your pattern. So I did the third one just to make sure you understand that whenever you get an immediate match, you have to use this process to find it. Whereas if you don't get an immediate match, that's why we use the table. Now you could use the table if you wanted to, but I think that it's easier to get it done the way that you learned the other day, which means that this is probably the best idea. Alright, so outside of these types of problems, there's really nothing else of importance for today's work. Your quiz tomorrow is going to cover all the work from this week, including the graphs and the 3 types of patterns. So make sure you study for the quiz so you don't have to plan a trip before after school to make this quiz up. Again, I think a lot of you are wasting your time because I hear you getting frustrated because you're saying you're working the same problem 2, 3, and 4 times in a row, and that doesn't make sense, especially if I'm sitting up there waiting for you to bring up a question so that I can help you out. Think about this. Most of the questions that you're having issues of have 2 or 3 of the same type. If you thought about why that happened, it's because that way if you have an issue with the first one and you just don't get it and you miss it once or twice, I would even say just once. Once I have an issue with it once and I don't get it, and you try to look it up and you miss it another time before you even get to the 3rd or 4th try, I would just bring it up. And what I do is I help you through it and explain the first one for you. So I take this out of your hands. That is why I give you 1 or 2 more so that you can go back to your desk and try what I showed you with the other 1 or the other 2, and then your time continues on. But if you are wasting 5 to 10 minutes on one question, or I won't say 5, but 10 to 15 minutes on one question getting frustrated, then you're really not making a good decision. So you might want to make sure you start actually using the teacher in the room, because that's what I'm sitting there for, is to try to help you out with whatever you're having issues with. Other than that, again, you got a quiz tomorrow. Make sure you're ready for it, and good luck today.